So the first thing that we need to talk about and review is the classification of matter. Now, just as a review, matter is anything that takes up space and has mass. And so there are pure substances within which you have elements and compounds, and then there are mixtures which can either be heterogeneous or homogeneous. And so this flowchart actually helps us a lot in deciding what type of matter we have. So if the matter that you have is not the same throughout, then you have what is called a heterogeneous mixture. So for example, if you have a solution that has particles, that has solid particles at the bottom, like a salt solution that has salt on the bottom, that's going to be a heterogeneous mixture because it's not the same throughout. But if it is the same throughout, for example, a salt water solution that doesn't have anything on the bottom, then you have what is called a homogeneous mixture. The next question you need to ask yourself if the matter is not a heterogeneous mixture is, does it have a variable composition? Basically, are there more than one type of compound or element within that solution? If the answer is yes, then what you have is a homogeneous mixture. And another name for a homogeneous mixture is simply a solution. So anytime you take a solid and dissolve it in water, that will create, if it's soluble, that will create a solution that is a homogeneous mixture. If you don't have variable composition, meaning you have the same compound or the same element, then it's going to be a pure substance. And then once you have a pure substance, what you need to ask is, does it contain more than one kind of atom? If it only contains one kind of atom, like for example, copper or sodium or just chlorine, then you have an element. But if you have more than one different kind of atom, for example, Na and Cl, sodium chloride, then you'll have a compound. So just as practice, I'm going to do the first one with you. If you have salt water, you know that you have a mixture because you have water and you have salt. And because salt water will be the same throughout, it will be uniform throughout, you have a homogeneous mixture. So what I want you to do right now is do the rest of these examples. The next thing that we're going to be talking about is properties of matter. Now, you can have physical and chemical properties of matter. So a physical property is a property that can be observed without changing the identity or the composition of the substance. So there are a number of different examples of physical properties that we're going to be looking at in this class. For example, the color, that's the most obvious one. You can observe color without changing the identity of the substance. Hardness, right, whether it's soft or hard. The melting point, the temperature at which it melts. One key thing that a lot of students misunderstand, melting, in order to melt something, you're not changing the identity of the substance. You are simply breaking the attraction between the molecules, but you are not changing the identity of the substance. So melting point would be a physical property. Solubility, the ability to dissolve, that would be a physical property because when you dissolve something, you are not actually changing its identity. And then density as well, because you can measure mass, you can measure volume without changing the identity of the substance. On the other hand, a chemical property describes the way in which a substance is going to change or react in order to form new substances. Physical and chemical changes now, very similar to properties, but a physical change is one that occurs when a substance changes its physical appearance but not its composition. So a really great example of this is any type of state change you have. If a substance is going from a solid to a liquid or a liquid to a gas, those are physical changes because the substance isn't actually changing its composition. You're not breaking any intramolecular bonds. So if you look here, notice that the intermolecular forces, the forces between different atoms, those will break. However, you are not actually changing the identity of the substance. You're not actually breaking up those atoms at all or those compounds, whatever they are. So if you actually change the identity of the compound by breaking it apart, then yeah, that would be a chemical change. But here all you're doing is weakening the attraction of molecules for one another. So that is going to be a physical change. Now, a chemical change occurs when a substance is transformed into a chemically different substance. So for example, if you have hydrogen gas and oxygen gas and they react, notice that the hydrogen atoms break apart from each other, the oxygen atoms break apart from each other, and then they form a new compound, they form water. So that would be a chemical change because you are breaking up molecules and you're forming new molecules. The next thing that we're going to be talking about, which should be review, are units of measurement. So we've got length, and one of the most common units of length is the meter. We've also got mass, and we can talk about mass in terms of grams or kilograms. We've got temperature. Now, the units for temperature are Kelvin, Celsius, and Fahrenheit. We are very infrequently, if not ever, going to see units of Fahrenheit. That's an American thing. What we're going to be talking about in chemistry is units of Kelvin and units of Celsius. So let's look at that conversion really quickly. Just as review, to go from Kelvin to Celsius, what you do is you take the temperature in Celsius and you add 273. So for example, if you're going to convert from 27 degrees Celsius to Kelvin, what you would do would be take 27 and you would add 273 to that to get 300. Now notice I put a decimal place here, just as review, and we're going to go over significant figures. When you're adding two values, you use the fewest number of decimal places. So here it would be 300 point Kelvin, just to make sure that you're not saying that the 300 only has one significant figure. But we will go over that in a future video. The units for volume, if you notice, can be in milliliters, and there are a number of different ways of actually measuring volume. You can use a graduated cylinder, which we will use in this class, a syringe, which we will not use in this class, a burette, which we definitely will use. Notice the burette, instead of starting at 0 at the bottom and going up to 50, it starts at 0 at the top. And the reason why is because you're going to drain that substance, and so it's a nice, easy way of just measuring how much has left the burette. Pipette, which we are going to use, which that bulb at the top suctions up the liquid, and then a volumetric flask, which is your most accurate way of measuring volume. Okay, and really quickly, as far as units are concerned for volume, your units tend to be either liters or milliliters, though you will see other units such as centimeters cubed or decimeters cubed. And the reason why it is cubes is because, remember, volume, to find volume, you take length times width times height. And so if you did that, 1 centimeter cubed, that actually equals 1 milliliter. All right, so the last thing we're going to be talking about is density. Now, density is the amount of mass in a unit volume of a substance. And so the formula for that is simply mass divided by volume. Okay, and if you look at all the different densities for substances, what you should recognize is the fact that the density is what determines whether or not something's going to float. So for example, if I have balsa wood, which has a density of 0.16 grams per centimeter cubed, and I put it in water, that balsa wood is going to float because balsa wood is less dense than water. However, if you take table salt and just put it in water without stirring it, it will sink to the bottom because it is more dense than water. So let's actually look at an example problem. It tells me that I have tetrachloroethylene, and it is a liquid that's used for dry cleaning, and it has a mass of 40.55 grams and a volume of 25.0 milliliters. It says, what is the density at this temperature, and will it float in water? Explain. So remember, the formula for density is mass divided by volume. Okay, I'm going to take the mass, which is 40.55, and divide it by 25.0. And so my answer, we will go over this in a future video, but just as review, because 40.55 has 4 sig figs and 25.0 has 3 sig figs, my final answer should have 3 significant figures. So my answer is 1.62 grams per mil. Now, if you look, the density of water is 1.00, which means that tetrachloroethylene is actually going to sink in water because it has a density that is higher than that of water.